Okay, this is a continuation of a discussion I had earlier today with one of my customers focused on a quick start. Earlier today, I showed you how to use the merge statement and how to use a row hash to detect whether column values are the same in a source row as the target row, in which case it's not really an update. Don't bother updating it. And now I'm going to show you how to use a window function to select the most recent of the rows that are coming in the input, streaming on the input side. And we're going to use the timestamp to detect which one's the newest one and use that to only apply the update once. Very common practice in event-driven systems. So I did a select. There's the 10 rows I'm going to grab. As before, I'm just creating a table called orders in my toy database, and it'll be those first 10 rows that you can see below. Next thing I'm going to do is, because the orders table that I've selected does not have an update date, I'm going to alter the table and add an update date timestamp column, and then I'm going to change each row to have the same update date. I'll set it to 12 o'clock, 12 noon on 4/22. So if I just run that, it's updated the 10 rows. If I select those rows, you can see at the very end that an update date has been added. Now, I just saw this feature here, so I'm going to use it to eliminate some of the fields that we don't actually look at when I'm looking at the result set, because these are the only fields I play with. So that's the orders table, and there's 10 rows. Now I'm going to pick 3 of the rows from the orders table down here, and I'm going to put it in the orders update table. The reason I do this is because I'm old-fashioned. I want to apply the update to the orders table, so I've called it orders update. Now, to see what's in that orders update table, there should be 3 rows. 1, 2, 3 is the order key. And the comments are here, just random noise, and the update date that I've set already. So everything is pretty straightforward up until now. What I'm going to do to facilitate our demo is I'm going to take order 1 and do 1, 2, 3, 4 different things to it. The first thing I'm going to do is I'm going to create an update record I'm going to update one of the rows so that it changes the name of the comment and the timestamp with which that occurred. Then I'm going to add a row. It just adds an additional row with the same order key, 1. And instead of saying the door is ajar, it says the door is ajar. And the timestamp is different. This happened at 1 p.m. or 1300 hours. This happened at 13:05, which is 5 minutes after 1. So I'm going to insert another record that, again, I'm just creating fictitious data to show how the update or how the window partitioning logic works and some of the limitations. And the example of the limitation, I'm going to add a final row for order key 1. It's a different comment, so it's literally different data, but if the timestamp is identical, then there's no way to understand which one will always appear. And so this is more of an example of what you should be on the lookout for. If your timestamp are so coarse-grained like this, you can get odd behavior because some of the information might be lost. So very few event-driven systems operate at the minute level, so this should rarely occur, but who knows. Now, the final record I'm going to change is order key 2, and I'm going to change the comment as well. So I will run this command again to select, and you can see that I've updated the first row, and I've added 3 more records just to demonstrate eliminating dupes. And you can see the difference between the rows are the update dates, and the final 2 rows, the door is open or the door is closed, both have the same exact timestamp. So in a situation like that, you can't keep 2, it will pick 1. And it's not deterministic. So you can't ensure you're going to get the one you hope for, and that's why it's considered bad practice if your event system is generating update dates down to the minute level. It should be down to the second, millisecond, or even finer grain, depending on what you're doing. Anyway, so if I select the update table, you can see here are the 6 rows. I've just put them up here for my own edification. And like I said, or like I used earlier today, I've tried to explain what each row is there to test. The first row is an update to order 1. The second one is an update to order 1. The third one is also an update to order 1. Each consecutive is also an update at the same time. And this will create non-deterministic behavior, which just means you can't tell what's going to happen, and you should avoid that. But I keep repeating myself. Let me keep going. So when you're presented with data like this duplicate data, and you want to pick the most recent one, the most common practice I've seen is people using window functions. So let me show you, if you're presented with data like this that has seeming duplicates for the same contact ID, or in this case, order ID, we're going to use a partitioning function. And it eliminates all of the older updates. It'll pick the most recent one. And you can see how the select statement works right here. If I just select the select statement and run this, you'll see what it does. And I can eliminate all of the columns I don't want. You can see what it does is, for order key 1, there's 4 of them, and it assigns them a row number. And that's the purpose of the partition by order key, order by update date descending number. And then so the next layer, so this is my common table expression, the next layer does a select star from the CTE where row number is 1. And so it'll always pick the first row based on that partitioning scheme. So the reason I'm showing you this is because I want you to see this is the logic, and it will result in only 3 rows being considered in the update file. But now we have to add that into the merge statement like we did before. So if I go to the merge statement that we were using today, it's merge into customer file as target, and then using as source, I'm going to have to take this simple logic and replace it with the common table expression and the select that I've shown you here. And that's a bit tricky. So I wanted to show it to you first, and then we'll scrunch it up and add it in. Now, before I can run the merge statement, remember I have to have a row hash on each of the rows in the orders table. So let me just add that column to the table and then update all of the orders and construct their row hash. Okay, so I've just updated the 10 rows. So if I look at the orders table, now I've got 10 rows with row hashes. So I can quickly compare them to the orders update table, which has a bunch of duplicate records and doesn't come with a row hash. And we're only going to calculate a row hash if we have to. So here's the magic merge statement. So it's identical except for this block here, using as source. And so what I do here, you can see, select star as row hash for or from, actually let's go into the innermost sanctum here. So with ranked orders as select star row number with the partitioning from orders update. This is my common table expression I showed you before, and then I select star from that table. I exclude the row number from ranked orders where row number equals 1. So I've picked the first one. And then that becomes my latest order table, or CTE. And so I don't need the row number anymore. That's why I excluded it. So I select all of the columns plus the row hash. Once I've done that, I've got a row hash only for the deduped rows, and then I can apply the exact same logic I did before. So when matched and the target row is different, the hash value is different than the source row hash value, then set it. So if it's matched and it'll just ignore it. It's just it's a repeated row, so I don't need to do any updates on the target table. If it's not matched, we assume it's an insert because we don't handle deletes. That's a different step, and I'm not showing it here in this video. And if it's not matched, it inserts it. The only difference between this merge statement from 130, which I'm going to email you, and the one from 120 is really just this using section where I define the source. And you'll see that this is for the customer table where the column names are different than the one in the orders table. Okay. Once I've done all of that, let's run the merge statement. What do we expect? Well, I hope you answered there will be no rows inserted. Actually, everything is updates. And even though there were 6 rows, only 2 rows got updated. And that is logical. That's what we expected. If I go to the orders update table, or I scroll this, I should have only had one update here because it'll pick the one that's the latest and apply it. And then this is an update, so there should have been 2 updates. Validating exactly our logic, and I've proved before that it will ignore existing rows, or I've proven that it can insert rows. And so what I've added down at the bottom of the script is, I said, well, let me just prove it to you again. If I insert another row into the update table, now the key is that the order key is different. It's not 1 through 7 or the other numbers. So if I look at the order update table, you can see there's a new order key that will be treated as an insert. So if I just go in this merge command and hit run again, it inserted the row. If I hit the merge command again, nothing happens. I hope that helps. I don't know if this video was worth it, but I appreciate it if you used it and it helped.